Hello everyone, I am Riaz-ul-Haque from Information System Design and Data Science course, and today I am going to present the course titled Computer System Design, and here is the outline of today's course. So the first two parts of this course is basically the summary part, and that discuss the computer system, having discussion a bit about the software and hardware, how it's work and how it interrelated with the software and hardware. And then I will discuss about the modern computer history. So the computer here looks is not like that in earlier, so how it comes from. And then the final and the main content of this presentation is basically the performance of the computer. So I will discuss the various performance parameter of the CPU that makes the computer faster or the high performance computing system. On top of that, I will also discuss about the domain specific architecture, which we call the hardware accelerator. For example, it will be used in various special purpose like data analysis, cybersecurity, graphics processing, and various aspects. So this hardware is specifically designed for a specific task. And on top of this discussion, I will also show you a demonstration of a Python script program. I will write a simple Python script, and I will show you how a program execute with a computer and how the software and hardware work together and execute a program and show you the result. So that's the main theme of this today's lecture content. And the end of this presentation, you will be asked to submit a report, and the report basically based on this presentation. And I will also upload a guideline for you that contains some topics and some guideline. Please read this guideline. You can follow the guideline or you can make your own report. Both are okay for me. And okay, so let's start with the presentation. And I think you guys enjoy the... I would like to start the lecture with defining the computer. So here I can say that the computer nowadays are the lifeblood of today's world. And to realize that thing, that what I want to explain, that think about the thing, if all the computer turns off together right now, what happened? The world becomes dark because the power grids are shut down. It crashes all the world. The planes will be fall down, the water supply stop, the stock market will be freezed. So nothing happen in the world it could be possible to continue. And here is some example where we use the computer, starting from the rocket, satellite, post system, your vending machine, automobile, traffic light, everywhere, including the home appliances. Nowadays, it is very difficult to find out the list where the computer is not used. It's a very robust application in various aspects, all are computer. And if you think that the computer can not just do the computing, it's running the whole internet, it having the artificial brain, and it can simulate the universe. But the most interesting thing is that all the thing that the computer is doing is just the flipping of zeros and ones. That's very interesting, that the computer doesn't understand anything except the 0 and 1. Well, as I said, that we have the computer, the software and the hardware architecture. Let's begin with hardware architecture. So hardware is the thing that we can physically achieve or touch, and here is the typical architecture that I want to explain, having mainly three components: the central processing unit, main memory, and the second memory. And with that, I'm including the interface to interface the input-output interface and the network interface. The task the CPU or the processor is for running the software program. And in main memory, that stored the program which is to be run by the CPU. And it's a bit expensive, and it typically is small because of the expense, and it's usually 8 to 64 gigabyte usually. And the secondary storage is store the program data and for the permanently. I mean, when the power is lost or the computer is shut down, this data is never been lost. So it's a bit cheap, and typically it will be the 64-bit to a few terabyte, 64 gigabyte to a few terabyte. And the interface is responsible for talking with the computer peripherals from the outside, like the keyboard. And we have also internet network interface. That's one of the main interface in the world, is computing this connection to computer to the internet, right? This interface is worked to connect the computer to the internet. Here you can see physical, as I said, that hardware is physically watchable. So here is an example of MacBook Pro version, and the hardware is look like that. As I said, that we have CPU, main memories, and interfaces, and the secondary memory. So let's try to find out the CPU. Here you are, is the processor, the Intel, by the Intel company. This is the RAM or main memory. And here in the two left and right side of the laptop is the interface unit that provides some interfacing like the display unit. And here in the blue bar is also a coprocessor, or it's called, it's especially used, as I said that I will discuss later, is especially used for a specific purpose. Here this specific coprocessor is used for security. So this is a typical structure, and you can see it if you broken a laptop MacBook Pro, and you can find this type of things. And even every computer you will find out these basic things in nowadays. So let's move to the software architecture. So before going to the software architecture, as I said, it's intangible and it cannot be visible. So the software having two parts: the software system, total system, and the program. Actually, total system build a complete packages having a combination of a lot of small programs. For example, if you can consider the software system, the word processor, Microsoft Word we call it, is a system that having a lot of program. And program itself is a set of instructions that tells the computer to do a very specific thing. We also call it the code. And this is the typical hierarchical structure. So on top of hardware, we have an operating system, as all of you know. So that operating system usually called the pair between the interface between the software application and the hardware. So all the application like the word processor is run through the hardware with the help of operating systems. So the example of operating system is like iOS, in Windows, Linux, Mac, etc. So now I will run a program using a simple Python script, as I said to you, and then I will explain how the software and hardware work together. Let's move to the live demonstration one. In this live demonstration, I will show you how a computer program works. The interface here is a typical computer interface, having a lot of program with different functionality. Among them, I will select a command line to write my program. So what program I will write is basically a simple Python script that says something to the computer to do with. So let's start to make a script. For example, the name of the file is a.py, and I write print welcome to Shimane University into that file. So now I have a script, Python script having some command. That command is well known to the computer. So let's try to run this program using this command line. So the command Python is for telling the computer to use the compiler to run something. And as you know, my file name is a.py, So this command is also a way of interacting with the computer using text, and as I said, if I run the program, it will show welcome to Shimane University. I mean, it's execute properly, so the computer understand what I tell him and computer work accordingly and show me the message according to the script. Now let's go to the slide and explain how it works in hardware and software level. So here you can see a print screen where I took the same thing and 3 lines. So first what I did is generate a Python script and save it into a secondary memory. I'm taking the pointer, it helped. So then I execute the program. That means tell the computer to execute this script, this program. And finally, after executing, we can show the desired output, welcome to Shimane University. Let's go back to the diagram, hardware diagram. I will show you architectural diagram here. CPU, main memory, interface, and the secondary memory. So once the program is running, so first the program a.py is copied from secondary memory to main memory. After that, this program is executed because the secondary memory is slower and far away from the CPU. And once the program is copied, the CPU executes each line steps of the program according to the program code. So the program code is break down into instruction, and CPU individually process every instruction, and once the coding is finished, you send it to the interface, I mean the display that shows the welcome to Shimane University. This is a very basic flow of computing hardware architecture and the software architecture. So I think you guys understand the basic flow of the computing. So now before going to the next step, performance, I will discuss a bit about the history of the modern computer. And here you are. So this computer I am talking with, I'm recording the video, is not like that in 50 years ago. So there are some generation of computer, but this slide, I don't intend to show you the generation, but the thing is that what I show, the earlier we followed the manual computer. This is abacus. Many market in Japan, you can get this type of device. So this is used to computing various arithmetic in earlier, before inventing the computer. And then this is one of the world's most powerful supercomputer right now with some. So this is a gap of hundreds of years. So that's the generation called sometime. But here I want to share that the vacuum tube and then the revolution of transistor, and after all the integrated circuit, and right now we are the era of the very large scale integration. So each microprocessor having billions of circuits. So this is the steps that we consider for various generation, and we are now in the modern computing era that we called. One more thing that I would like to discuss, there's a few terms are used to represent the computer performance, etc. So here you are. Operation bit. This is a capacity of a processor. In the early processor, it was only the 4-bit. I mean, a processor can operate only 4-bit data at a time. But nowadays, it's going to 128 bits. Modern computer, some of the modern computers are capable to process a data with 128 bit at a time with a single instruction. Regarding the clock speed, the early computer was measured in a kilohertz scale, but now it's down to gigahertz. The number of transistors in the early computer was a few thousand, but now each processor having billions of transistors. Same for the core, the early modern computer having a single core, but very recent it's increasing and it's now sometimes more than 100 in a computer. In case of supercomputers, few thousand. Also in the processing, the early modern computer having the single instruction at a time sequentially with the single data. But now we have superscalar that can be able to operate multiple data and multiple instructions simultaneously at a time. The last thing that I would like to share with you guys is a comparison. So now we have a very small thing like, let's move to pointer again. I forgot to make it. Okay, so we have mobile phone or even more smaller, that is smart watch or a smart glass having a processor, huge capacity that is for the single user. Laptop or PC is also for the single user, and then a mini computer can be used several users simultaneously, and more capacity is mainframe, and supercomputer is much more higher. The thousands or millions of people can be used at a time simultaneously. Here is a comparison that I say the first supercomputer, 1965, the power was 3 million calculations per second at that time. Can you imagine? 10,000 times slower than a iPhone 12 right now. That supercomputer is 10,000 slower than a small smartphone right now. Now come to the modern powerful supercomputers, made having more than 36,000 processors, and the capacity is 200 quadrillion per second. It's huge. It's not just a million or billion or even trillion, it's quadrillion. What happened next? So the next is a new scale we need to explain, because the computer power is exponentially increasing, the hexascale. The hexascale is basically a computing, that scale is measured by the billion times billion per second. We will soon very nearly a supercomputer having this scale. So that's the end of the first part, where I discussed the basic flow of computer, the software architecture, hardware architecture, and some history and evolution of computer, and few terms that we should know regarding the computer architecture. Now we'll move to the second part of this course, which is performance of computer. So if you finish to watch this video, move to the next video. I will explain the various parameters that is defined to increase the performance of computer. Thank you for watching.